Hey everybody, how are you guys? Hope everybody's good. So we're going to continue right along with where we left off. So we were talking about light as energy and as a wave and different functions of the wave. We did some calculations based on frequency and some wavelength calculations that we were doing. So we're just going to continue on from there. We're going to look at the main component of all of this light that we've been talking about. So this is the electromagnetic spectrum. And as we learned from last lesson, we learned that light is a form of energy. We know that it can be transmitted without transmitting through matter, so that's why it can be transmitted through the vacuum of space. For us, in terms of our perception, there's only a very, very, very small band of the entire electromagnetic spectrum that we can actually see, and we call that the visible spectrum. Okay, and it allows us to use our eyes. Our eyes are sensitive to the visible spectrum. Of course, there's other organisms that are able to go outside of that visible spectrum. And the sun actually produces all of the frequencies of light that we're going to be talking about today. In terms of what it is, well, electromagnetic radiation is a wave pattern that is made from two components. One of them is going to be an electric component, the other one is a magnetic field, and they travel through space. The electromagnetic spectrum is the range of all of these different components and whatnot. And it ranges starting at very large wavelengths all the way down to very small wavelengths, but we'll fill that out as we go. So this here that I have below is the, there we go, is the electromagnetic spectrum. And when we're looking at the entire spectrum, you'll notice a couple of components. So as I go from left to right here, you'll notice that this line represents frequency. And here we have very low frequency. And it increases to very high frequency. You'll remember that according to last lesson, frequency had a relationship that was inversely proportional to wavelength. So down here, the other arrow that's way down at the bottom, this represents the wavelength. Remember, we measure that in meters, and we use the letter lambda to show that. Frequency, we use two letters. We use the F for frequency, but we also use the letter nu for frequency in terms of physics. Here, these are measured in meters or centimeters. And up here, of course, we have this as either hertz or seconds to the minus 1 or 1 over seconds. In terms of the entire spectrum, the largest wavelengths are over here, and the smallest wavelengths are over here. So big lambda on the left, small lambda on the right. Now in terms of the electromagnetic spectrum, way down at the bottom, in terms of the frequency, the lowest frequency waves, they are called radio waves. Okay, and radio waves have a ton of uses. Usually it's telecommunications. Immediately following the radio wave, so now we're getting smaller in terms of wavelength, but larger in terms of frequency, we have our microwaves. And of course, we use microwaves for lots of different things. Some of it is communication. Heating food is another thing, or heating. Okay, so we use microwaves for that. Immediately in front of the microwaves in terms of higher frequency, smaller wavelength, we have infrared waves or infrared radiation. In terms of uses, we usually use these for things like heating or night vision goggles. Okay, so those are some uses here. And then we get into the visible light, light part of the spectrum here. Now this is of course the smallest, or one of the smallest components of the electromagnetic spectrum, but I want you guys to really pick out here the words that we're using. So here we start with red. Red light has the largest of all of the colors in terms of their wavelength. It has the lowest of the frequencies in terms of the visible part of the spectrum. And take a look at the word that we used before in the previous set. We used infra. Infra means below the, so infrared is below red in terms of the spectrum. Your eyes can see basically from here to here. So this is what our eyes can see. And then of course we know all of the different colors of the rainbow. So I'll zoom in here so you guys can see. So we've got red, and then we've got orange, and then we've got yellow, and in the middle we've got green, and then we've got blue, we have indigo, which is like a type of purple, and then violet. Now violet light is at the upper end of the spectrum in terms of our ability to see. It is by far the most, the highest frequency light that we can see. It also has the smallest wavelength in terms of what our eyes are able to see. In terms of uses, I mean, there are limitless uses, but obviously seeing is one of them. I'm not giving you guys too many uses here because I do want you guys to go on and do a worksheet that I have. It's a graphic organizer, and I'll show you how to get to that, or I'll tell you how to get to that in just a second. Immediately following violet, what might you think, what word we might want to use? Well, if we used infrared for below, is there a word that we can use for above? And there is. We call that ultraviolet. In terms of ultraviolet, UV radiation, we use that for lots of different things. So one of the things, of course, is getting a suntan. But there are lots of other uses for it. So suntan is that. And then after ultraviolet radiation, we get into X-rays. These ones are kind of self-explanatory in terms of what their uses actually are. So this is medical diagnostics. So you break your hand or something like that, you break a bone, that you have to go in for X-rays, and the doctors are able to, of course, then see what's going on the inside of you. Now we're still increasing in terms of frequency and decreasing in terms of wavelength. So these are very small wavelengths, really, really, really tiny. And then as we go towards the last one here, we get into very small wavelengths with very high frequency. And the last one is called gamma rays. Okay, and gamma rays are very, very, very dangerous. They require extreme safety. We don't actually get any of these that are being given off from the sun here on Earth. The Earth's magnetic field actually blocks them. But we can recreate these on the planet, and you're probably wondering, well, why would we want to do that? Well, they're very harmful to organisms. So if we are trying to sterilize something, gamma rays may be a good option for doing that. So you have some bacteria you want to get rid of, you fire some gamma ray radiation at them, and the bacteria die. And so you can use these for sterilization. That's a good use. Now, in terms of what you are going to be doing now, there is a more complete electromagnetic spectrum posted on the website, and there is also this electromagnetic spectrum graphic organizer. So this is posted on the website already. Go to the website that you see at the top here, the darville.clara.net/emag, and you will be able to fill out this chart here. So we'll look at the name. So we start at gamma rays and work our way down. How is it produced, or how is it made? And then, of course, more uses. Now, I'd like you guys to focus on uses that I haven't given you already in the lesson, and then any of the dangers that are associated with them. Now, before we finish that, I do want to touch base on a very special line here, and the line actually is right here. So I'm going to separate out our electromagnetic spectrum. these components, which I'm going to just quickly erase this little I here, if it'll erase. There we go. So everything from radio waves all the way up to violet, we call that non-ionizing radiation. Now, non-ionizing radiation is not dangerous to us. Okay, so you can stand in front of your microwave for hours on end, and nothing will happen to you because the microwave radiation that comes out of our microwaves at home is actually possesses less energy than the light coming out of the light bulbs that we have illuminating our rooms. Everything beyond the line between violet and ultraviolet is what we call ionizing radiation. And ionizing radiation has the potential to damage cells, in particular damage DNA, and can cause things like cancers and other things like that. So just something to think about and look at. That's it. Nice short lesson. Go and fill out that sheet, and that would have been a typical class at school. See you guys next time.